Here we've got ammonium nitrate, which is actually a fertilizer. If anybody remembers, a couple years ago there was an explosion at a fertilizer plant in a city called West, Texas. And ammonium nitrate is actually very highly flammable. I'm pretty sure that this was the fertilizer that was part of the explosion. I'm just trying to get my camera to focus and want to stay focused right now. I'm sorry, guys. All right. So when it does decompose on its own, it produces dinitrogen monoxide and water vapor. Okay, so here's our ammonium nitrate. It's decomposing into these two substances. Okay, we want to know how much water vapor is produced from the decomposition of this mass of solid ammonium nitrate. All right, before I go through and highlight everything, help me read the problem, the first thing I'm going to do is balance my chemical equation. Okay, this one is a little bit trickier than some of the ones that you may have done in class or in the previous examples. So I'm going to go ahead and just do it the old school way and write down my different elements. I've got nitrogen, I've got hydrogen, and I've got oxygen. Okay. In my reactant side, I've got 2 nitrogens, 4 hydrogens, and 3 oxygens. And in my product side, I've got 2 nitrogens, I've got 2 oxygens, and 2 hydrogens. Okay, to me 4 and 2 is a lot easier to fix than 3 and 2, so I'm going to go ahead and multiply this by 2 over here. That way, instead of 2 hydrogens, I've got twice that, which is 4, so now my hydrogens are balanced. Okay, and if I look at my oxygens now, I've got 2 times 1, so 2 plus 1, 3. Okay, that helped balance everything out. Okay, so this is my balanced chemical equation, which means 1 mole of ammonium nitrate will decompose into 1 mole of dinitrogen monoxide and 2 moles of water vapor. Okay. Now I can go back and look for my number unit substance to see what they gave me. Okay, so it says, here's a bunch of information. Determine the mass of water vapor produced from the decomposition of, this is my number, 25 unit grams of solid ammonium nitrate substance, number unit substance. So I'm going to try to keep the same color scheme I've been using. I've got this information that I know, and I'm being asked to find the mass of water vapor produced. Okay. So again, just like the previous problems, I'm going to begin with what I know. So I've got 25 grams of solid ammonium nitrate. Okay, so I'm just going to write this right here, NH4NO3. Okay. Now, I don't want to talk about grams of ammonium nitrate anymore, so I need to set up dimensional analysis to be able to cancel that out. Okay, let's go ahead and draw that out. So I don't want to talk about grams of ammonium nitrate. So I'm going to put that in the denominator. That way, my grams of ammonium nitrate cancel. Now I'm kind of stuck figuring out what I'm going to put in my numerator. Okay, if you recall from Unit 5, the mole, if you know mass of a substance, the only thing that you can find directly using conversion factors is the moles of that same substance. Okay, so if I've got grams of ammonium nitrate on the bottom, the only conversion factor I can use is to go from grams to moles of the same substance. So I'm going to go ahead and put that up here, moles of ammonium nitrate. Okay, all right, now I don't want to talk about, there goes my lights, hold on. All right, I don't want to talk about ammonium nitrate anymore, let alone moles of it. So, again, I'm going to go ahead and cancel that out by putting these units in the denominator. So I've got moles of ammonium nitrate here on the bottom. Okay. So for moles of ammonium nitrate, I could either go back to grams, which is pointless because I just got out of grams. Okay, I could find how many formula units that is, but that doesn't really help me if I'm asked to find something about a different substance. So since I've got moles here and I'm asked to find a different substance, I'm asked to find water vapor instead of ammonium nitrate, this is a great opportunity for me to use my mole ratio and say that I can relate the moles of ammonium nitrate, let me go ahead and show you this cancels still, to the moles of water vapor like I was asked to find. So again, here at my mole ratio, I'm getting out of one substance and into another. I'm converting between substances. All right. Now it asked me to find the mass of water vapor, though, not the moles. So more dimensional analysis. Got just one more step. Okay, I'm going to put moles of water vapor in the denominator so that way they cancel. Okay. And so let's show that those moles of water will cancel. And from moles I can get to mass of water vapor, so I'm going to go ahead and write that in. I'm about to sneeze. Excuse me. So I'm going to try to put the grams of water vapor on top. I'm not going to try, I will succeed in putting grams of water vapor on top. Alright, so now I know that all units have canceled except for my desired unit, so I'm going to go ahead and put my little equal sign, and it's okay if you carry that down, and put my unit and substance in my answer, so that way I don't forget it later. That way I know I found the right thing, that's mass of water vapor like the question asked for, and I didn't forget to put it in my answer. Okay. Now let's go back and plug in the information we know to our conversion factor so we can do the math. Okay. Again, the first conversion factor that I will always do is the mole ratio, and that's because, again, all I have to do is pull some information from my balanced equation. Okay, I can relate the moles of water to the moles of ammonium nitrate by looking up here. I'm going to have 2 moles of water produced for every 1 mole of ammonium nitrate. So I'm going to say 2 moles of water for every 1 mole of ammonium nitrate. Okay, now I'm stuck filling in these two things. So if we could look here for ammonium nitrate, this is moles and grams, so we're going from grams to moles. The only way to get from mass to moles or moles to mass is molar mass for this compound. Okay, so let's look here, and then also here I'm getting from moles to mass of water. Again, I'm going to need to use molar mass, but for this compound, so I need to calculate 2 different molar masses. Okay, so I'm going to go ahead and kind of off to the side say the molar mass of ammonium nitrate. Okay, and I want to also calculate the molar mass of water. Okay, just kind of put this off to an aside, that way we know that if you're looking back at this video that this is the answer to the dimensional analysis part, and this is just information we need to be able to fill out our conversion factors. Okay, so the molar mass of ammonium nitrate, I'm going to take the molar mass of nitrogen and hydrogen and oxygen. Okay, I've got 14.01 grams per mole for nitrogen, 1.01 grams per mole for hydrogen, and 16 grams per mole for oxygen. Okay, again, these numbers come from the periodic table. Okay. Now I've got 2 nitrogens here, so that's 28.02 grams per mole. From nitrogen, I've got a total of 4 hydrogens here, so that's going to be 4.04 grams per mole. And then for oxygen, I've got 3. Okay, so it's going to be 48 grams per mole. And if I add all that up, I should get something 0.06, so 1620, 4, 8, so 80.06 grams per mole for ammonium nitrate, meaning there's 80.06 grams of ammonium nitrate for every mole of ammonium nitrate. So if I look here, I've got grams and moles, I've got 80.06 grams for every mole. Okay, we can calculate the same thing for water. It's a much smaller compound, so it should take us less time. We've got hydrogen and oxygen, got 1.01 grams per mole for hydrogen, 16 grams per mole for oxygen. We've got 2 hydrogens and 1 oxygen, so that's going to be 2.02 grams per mole plus 16 grams per mole. Add them together, you get 18.02 grams per mole. Meaning, if I'm talking about water, every 18.02 grams of water is just 1 mole, and 1 mole of water weighs 18.02 grams. So, 1 mole of water weighs 18.02 grams, or there's 18.02 grams of water in every mole of water. Okay. Now that our conversion factors are all set up, and I've made sure that all of my units cancel and leave me with my desired unit, I can do the math. Okay, So I've got 25 grams of ammonium nitrate divided by 80.06. So 25 divided by 80.06. Okay. All right, then times 2. So what I usually do is I'll hit enter between each step, but I never clear it out or write it down. Okay, so times 2. So see how it says answer times 2? It takes my answer from the previous step and multiplies it by 2. Okay, and then times 18.02. Again, we'll put that there for me. Okay, so I get 11.25 grams of water produced. Okay, now I want to go ahead and kind of mention, kind of get this turning in your brain. Okay, the law of conservation of mass says whatever mass of my reactants I have has to equal the total mass of my products. Okay, so I only have one reactant here, and I began with 25 grams of ammonium nitrate, and I only produced 11.25 grams of water. Well, that means that whatever mass of dinitrogen monoxide I produce has to add up with 11.25 to equal 25 grams. Okay, so in another problem I could even ask you to go ahead and find that, but we'll get plenty of practice solving problems like this in our next little chunk of notes. There's the lights again. Okay, here we go.